Good morning. My name is Misty Brave, and right now we're in the kitchen of the Lakota Science and Engineering and Technology Building. We're housed at Piowachoni campus, which is right outside of Kyle, South Dakota. This morning we're going to be doing a purple cabbage lab using purple cabbage as an indicator. In front of me, you see several household items, things that you might actually use to clean products or things that you might actually put in your body. Before you do any experiment, however, you have to prepare yourself. And one of the things that I always encourage is that for people should wear an apron. And you can see I'm going to put my apron on. And then also, whenever you're working with any kind of chemical, even though these might be household things that you work with every day, you always want to make sure you wear safety goggles. So I'm going to put these on. Right here, we have the purple cabbage. But the purple cabbage has to be worked with before we can actually do any experimenting. We have to grind this purple cabbage, and then we have to filter it. And I'll walk you through a little bit of the processes in case you want to try this experiment at home. After you've shredded some of leaves up, then you put a little bit of distilled water in the blender. Okay, we'll take this out. Coffee filters. We're in the kitchen. So oftentimes when you're doing science in the kitchen, and I call this kitchen chemistry, you use what you have that's available. If we were in the lab, we would probably be using regular filter sheets, but coffee filters are just as good for our needs. You can see that it's starting to filter through. Oh yeah, I was sitting here thinking, by the way, when you get all your cups together and filtering things, make sure they're clean. I remember doing this lab one time and I hadn't cleaned out the cups real good. And as soon as I put the purple cabbage in one of these beakers, it changed color. So I had to basically kind of start all over again. So just make sure that everything is clean. And I went through before and wiped everything off. And if you have to put on a new filter like I just did, that one was getting pretty full. Be real careful when you take it off, because you really don't want pulp mixed in the liquid that you drained here. Okay, we're going to be using some different indicators. First kind of indicator is blue litmus paper, and then we have red litmus paper. They're going to be used first to determine if the subject or the object is acid or base. Then the next one we're going to use is pH paper. On pH paper you can see it has different bands of color. And you dip it in the substance, and then we'll match it up to the color. pH paper is to determine the actual level of acidity or basicness of the particular substance that you're testing. We've previously put substances in the first 3 cups. Now we're going to put Lysol in this cup. It really doesn't matter how much you put in the cup. You just need to make sure you have material in there. This is our baking soda. Sometimes being unscientific can be fun too. This is the Resolve. This is the vinegar. This is mustard. For those of you that got out your lab sheets, you'll notice that there's no space to put in the data for mustard, so you're going to have to make one more line so you can put the data in. Decided to add another acid in, and this is the distilled water. Now what I'm going to do is go back through and add a little bit of distilled water to each of the substances. Oftentimes these things, when they're a clump like the toothpaste is, you don't want to test the clump, so you thin it out a little bit with some distilled water. And of course with the baking soda you have to mix it up in a liquid. This is your Resolve, vinegar, and mustard. Remember, the first test I'm going to do is with, we're going to start testing, and remember we said the first ones we're going to use are the red and blue litmus paper. I'm going to use, if you notice, there are stirring sticks between the different substances. Each one has its own stirring stick. Now, why do you think we might want different stirring sticks, each one having its own? Simply because of a thing called cross-contamination. We don't want to accidentally put this substance into here. It might affect the outcome of our experiment. So we kind of take care of that. Okay, here's your red litmus paper. We're going to dip it in the Dawn detergent, and look what happened. Red turned blue. Now we're going to try the blue litmus paper and see what happens. Blue stayed blue. Now this is what you put in your mouth. This is AIM toothpaste. The red litmus paper stayed red. The blue litmus paper turned a little pink. Just a little bit. It's not a whole bunch of change, a little bit of change though. we'll do the red litmus paper for the lemon juice. Pink stays pink, red stays pink, red stays red, I should say. Okay, we'll put the blue in. And look at that, the blue turned pink. Now this is a cleaner, Lysol toilet bowl cleaner. Pink is kind of staying pink. And the blue turned pink. Baking soda mixed with the distilled water. Pink turned blue. And blue stayed blue. Resolve, well, that's a definite change. Pink, the red turned blue. And the blue stayed blue. The vinegar, red stays red. And blue turns pink. Or blue turns red. It's not. I keep saying pink, but it's really red. Red and blue litmus paper. And here we go with the mustard. With the mustard, the red litmus paper stayed red. And the blue litmus paper turned red. Now we're going to do our distilled water. Distilled water should have a pH of 7. It should neither be an acid or a base. Blue stayed blue and pink stayed pink. Okay. All right, now for our second test, we're going to check the actual acidity levels of the different substances. We already know that some things are acids and some are bases. And we will talk about operational definitions using litmus paper during class. Okay. For our second test, we're going to determine the strength of this substance that we're testing. And we're going to use these papers, and they're called pH papers. And you see how they have bands in color. The acids are the lower numbers, and they're pinks and yellow, orange on this end. And then you have the bases, well actually 7 is neutral, and the rest of them are greens and dark blue, and those indicate whether they're a base. This is the base side of the test paper. Okay. Okay, this is our Dawn detergent, and it's testing out on kind of the greens side. It's darker than 7. It's if you wait a few seconds like you're supposed to, it's an 8. So record in your data chart 8. That's the actual pH. So it's a little bit basic. Okay, we're going to try the toothpaste. Now, according to the toothpaste, when we did it, it was supposed to be neither acid or base. And at the very, very tip of this indicator paper, I don't know how well you can see that, it is the color. It is pH 7. Okay, at the very tip, you can see that color of 7. The acid, wow, look at that, and that's lemon. That's what we like to eat. It's a pH of 1. That's a pretty strong acid we eat, isn't it? Okay, now this is it's testing out to be a 1. That's interesting. I'm going to try a different piece of pH paper. Okay, now we're going to try okay, this is turning out to be pretty strong baking soda. Looks like it might be about a 9. The Resolve carpet cleaner looks like it's about an 8. In between an 8 and a 9 maybe. Now we have the vinegar. And look at that. Wow. How many of you like pickles? It's probably a pH 2. Not as strong as your lemon. We'll try the mustard. It likes it. Might be about a 3. The mustard just might be about a 3. And finally, the distilled water. And once again, if you look at the very, very tip of that paper, it looks like it's a pH 7, of which it should be. All right, we've left those pieces of indicator papers in front of them, and we're going to now use the purple cabbage to determine if something might be an acid or base. You're going to see some pretty color changes here. Okay, now it's purple. It's purple. When I put it in the dish soap, what color did it turn? It turned a dark blue. Okay, now we've got the toothpaste. It stayed purple, and that's good because you don't want an acid or a base in your teeth, on your teeth. So it's neutral. Oh, now look at that pink. And if you noticed, when we did the pH test, it was pink as well. This is your lemon. Now we have your cleaner, and it looks like it turned a pink as well. a pinkish color. I think you can see that. Okay. The baking soda, we decided it was a base, and it turned blue, which was the same color of the pH paper. The resolve doesn't turn at all. It's neutral, and that's what our other tests showed as well. The lemon juice, I'm sorry, the vinegar, pink, same color as the pH paper, pink. Now we have for the mustard, and it's an orangey pink. It's definitely not orange, or like it was yellowish orange with the mustard. And then you have your distilled water, which is purple, which simply means that it's neutral, neither acid or base. Well, this is the conclusion of our purple cabbage lab. I hope you enjoyed it. You can replicate this in the kitchen with your kids if you feel like it, and we'll see you again.